my friends. Greetings, one and all, energy disruptors and incumbents. Because as we've heard this morning, this is very much a story of collaborative approach. This is very much a story of embracing everyone. And very much the panel I'm about to host, the privilege of hosting, you've already heard from Chris, is going to talk about where that might come from in this scenario of, well, let me put it like this. A friend of mine who's been on this stage, well, in the other venue, actually, to be more specific, Simon Moores said in a conversation, in a presentation to the US Senate Energy Committee in February of 2019, we are in the midst of a global battery arms race in which the United States is a bystander. Now, it's not just the United States, it's Europe, and of course it's Canada, and a number of other places. But fear not, we are here to give you hope. I think in the story of much of what we heard this morning, especially Peter's opening, you've got to be realistic. You can't, just fluff up things and say everything's going to be all right. Trust me, I'm a doctor. But what you can do is start to investigate the art of the possible and look at where things are. So we're going to do that with a wonderful panel. As I mentioned, you've seen Chris, founder of E3 Lithium. We've also got Amanda Hall, who's Chief Executive Officer and founder of Summit Nanotech. And if you know anything about batteries, we have a legend about to walk onto the stage, Mr. Bob Gallion, former CTO of CATL, the biggest battery company in the world. They have something, I think, at the moment around 37% market share. And Bob was there at the very beginning. Bob worked as an American in cooperation with a Chinese entrepreneur. There's a message and a story in that. To talk about what was going to happen. So could you please give your appreciation and a warm welcome to the stage our three panelists. Thank you. How you doing? Oh, it's you again.
I know.
Yeah, welcome. Hi, Bob, how are you?
Hey, Roger.
Hello.
Hello.
I'm pretending like I've just met them. We were all backstage a moment ago, but this is what you do. So, yeah, let's crack on with it. Bob. And let me check something else. Hands up if you've been to China. Who's been to China? A small number, not that many. You've been once or twice, haven't you, Bob?
Just a couple of times.
Yeah, just a couple of times, yeah. So let me ask you this question then, Bob. Given that China has such a lead at the moment with current battery technology, dominating the landscape, how can I put this diplomatically? How do we relieve them of that burden and responsibility? It's a bit unfair, isn't it, expecting them to, do all of this hard work, all the heavy lifting. Can the West catch up?
Well, I have to answer it with a long-winded question, or answer to that question, Roger, because it's not simple. I think Chris did a great job of kind of priming the pump, but I'd like to start out, first of all, saying I am retired from CATL. I'm not representing them in this forum, but I can give you the observations that I made in my 7.5 years as employee number 2 of CATL and watching it grow into a Goliath that it is today. First and foremost, there's 4 reasons why China excelled at making great batteries. Number 1 was government support in the way of incentives and their tax structure in order for them to be very efficient in making the business side of it work. The second part of it was the support by the private equity sector, because they figured if the government's going to support it, why shouldn't we? Because we'll get better returns. And at that time, China had a lot of money from sugar, flour, electronics, steel, oil, just about anything you can imagine. They were making money, but they could get better returns on their investment because it had good government oversight, if you will. A third reason was technology. Technology was available. I know that many of you think, well, China may have some kind of a master plan of becoming the Goliath of the battery manufacturing world. It fell in their lap because the whole world sent their consumer electronic product requirements over 20 years ago to China. In order to make consumer electronics, you have to have batteries. To make batteries, you have to have precursor active materials, and to make precursor active materials, you have to have something that can process the raw minerals into something that you can build into making those. But the fourth one is probably the most important, and in my role as a CTO was what I called the man in the machine, men and women working in the factories, men and women working on designing the battery product itself, how they contrive the process in manufacturing plants was remarkably difficult because you're scaling something that you're building consumer electronics in the kilowatt hour range, and now you're scaling manufacturing plants to the gigawatt hour level. The other part of the M&Ms, not the cute little chocolate things the grandkids steal off my desk, the other one is the machine. If you can imagine designing a machine that's going to produce something at the gigawatt hour level in parts per billion failure rates, it's remarkably difficult.
Yeah.
But that's what made CATL so successful, where we were able to train the men and the women, all aspects of the business and the manufacturing equipment itself in the plants. And if you ever go into one of the CATL plants, the flow of materials through the plant is remarkably smooth. It's really, really good. And I think there's another thing, and Roger, you've heard me say this, and I've kind of inserted this into the speech here, is the 5 golden rules of electrification. And,
oh, right. What are they?
You like those, don't you?
Go on then.
So this is something that I started when I was president at Magna E-Car here in Canada, over in Aurora. Safety, performance, life, cost, and environmental. If anybody wants to get into the battery business, if you really want to excel at that or be one of the suppliers, then you have to follow the 5 golden rules of electrification. And maybe later, if there's some questions from the audience about certain types of battery technologies. Right now, I'm working on no less than 9 different electric chemistries, just because I want to and because it's fun. And I think another key point is that everybody wants to try to get on an even parity with China. And I'm thinking, why? The only way you're going to beat China is have a leapfrog technology. That leapfrog technology has to circumvent the normal protocols that are followed in making a lithium-ion battery.
Yeah.
So the leapfrog technology includes cheaper, better, and faster mantras.
Right. Well, on that point, I love the idea of flipping the script, by the way. That's what we do. So, Amanda, if we're going to talk as my battery dangles, is this a Chinese battery that I'm dangling here, Bob?
I don't know what you got in your speaker over there.
So, DLE, direct lithium extraction. Can you give everybody in the audience a quick 101 on what that is? Because that could well be one of these innovations Bob's talking about to help us flip the script, leapfrog back the other way. What is DLE lithium?
Yeah, I'd love to. I'm a geophysicist, so this is right up my alley. Go back to the Big Bang, when gases were swirling and matter was swirling to create our planet. The entire outer shell of the Earth is called the lithosphere. It's called the lithosphere because it's got a lot of lithium in it. And so it's all over the planet, really. It's embedded in hard rock granites in Australia primarily, in other places too, northern Canada, and in the US as well. It's also embedded into some sedimentary rocks and clays. We find those all over the world too. And then there's these beautiful salars, primarily down in South America, where the lithium wore off of volcanoes and pooled into beautiful basins that were buried very shallow under the Earth's surface. And so the way we extract lithium from the planet is either from hard rock, clays, or brine. Direct lithium extraction, DLE, it takes the process of pulling lithium out of brine and it turns it on its head. And so traditionally, brine is pulled out of the ground and put into an evaporation pond, and 99% of the impurities precipitate, leaving lithium to be the last thing in solution that is then processed and turned into a battery material. What we do with DLE is we flip that over, and we say, let's pull the brine out of the ground, directly take the lithium from the brine, and then put everything else back. And so it completely changes the game when it comes to extracting lithium from brine. It doesn't change anything with hard rock or clay, though. Those stay the same.
Okay. It sounds so good that some music almost started
I
playing as you
know.
were describing that, which is impressive. Chris, so you're both in this business of DLE. If it can be scaled up, and I'm sure you're going to say it can, how quickly can it be scaled up? And will it eventually replace, for example, as you just mentioned it, hard rock, which is incredibly energy intensive to produce the lithium from it? So what's the journey going to be over the next, year, 2, 3 years?
Yeah, I think right now, the way the world is working is we need all the lithium we can get, right?
Yeah.
With all of the battery manufacturing that we're scaling up, we need all sources. We need the hard rock, we need the clay, we need the brine sources. And we need both types, solar and evaporation pond, or DLE sources. But in the future, as you look towards sort of normalization of the market and battery demand and lithium supply start to be a bit more prevalent, you have to imagine that right now, like lithium in batteries and lithium sources, before the lithium-ion battery, we needed 50,000 tons globally a year. By the end of this decade, we need 3 million tons. And it's only been in the last 10 years that we needed to scale this. So all the lithium we need to bring on to supply these batteries has to be built from new sources. And so we need all of it. But when you look at the advantages of direct lithium extraction, and it is a bit of a garbage can term of a bunch of different processes, when you get down to what we're really talking about is what Amanda was saying, is that it's the ability to remove the lithium from brines directly. And it's not that complicated. When you open up the black box, it's processing and technology that we've used elsewhere in other industries. The best analogy is water treatment. If you're taking calcium out of water in a water treatment plant, you can take lithium out of water in a water treatment plant. The same processes apply. And so from that perspective, it's very easy to grow and scale this. The challenge, though, is that the technology is new. And as I was alluding to at the beginning of my talk, new technology just takes time. Batteries are the same. It takes time to develop it, to engineer it, and then to commercialize. And right now, almost every project has moved in lockstep with each other. We're at the commercialization stage. So the first project commercialized this summer, the first big one outside China.
Bob might know the answer to this question. Is China developing DLE? Do you know, Bob?
I am not aware that they are developing DLE at the rate that they are doing it here in the United States.
Yay, we're winning on something. Yeah.
Almost.
Oh, okay.
No.
Right. Okay.
They produce,
sorry, I got carried away. I went too soon.
They produce about 80,000 tons out of DLE.
Right. Now, here's the thing. The Inflation Reduction Act, call it what you will, I mean, I like your description of it earlier in your presentation, is trying to align critical supply chain, both digging up the stuff, getting the stuff out of the ground or whatever, and preparing it. That's good. So let's say they get that ready, for argument's sake, in 3 years. And then you've got the other end of the scale. Hopefully, a lot of people do want electric vehicles, because that's predicated on will that market be there, assuming it will. Bob, what's the sequencing in getting this right? Because will we have built the gigafactories that are then ready to take all of this material? Who's project planning this? Is there a Gantt chart with it all on? How does it work?
Well, the Gantt chart for building a gigafactory is remarkably large.
I imagine it is.
So just to calibrate everybody's thinking, a typical gigafactory that makes 20 to 30 gigawatt hours is about 40 acres under roof. It's a huge plant. But I want to address it in a different way, Roger, because we talked about alternative technologies. Why do we need to consider sticking with exactly the same technologies we have today? Because we need every kind of battery that there is able to be made, including those with alternative technology to nickel, manganese, cobalt, or lithium iron phosphate. Such as an example, a corporation I'm working with, and the CEO resides right here in Calgary, is Linova.
Right.
Linova is using a polymer technology in the cathode. It's a specially doped cathode material made of a polymer from oil that's coming from crude, and we already have the resources to pump plenty of oil out of the ground and convert it to a polymer and create active material. So we already have an infrastructure in the United States, in Europe, and other parts of the world that can make other alternative technologies other than just relying on metals. But again, we need them all.
Yeah, I mean, look, this is very much a theme that's coming out. It's almost like the answer to the question, what's best, what do we need, is, well, it depends. It depends on where we are, depends on duty cycle of the application, it depends on a bunch of things, I guess. In terms of catching up, the topic of this discussion, one thing we haven't yet seen really at scale around the world, arguably, is bidirectional charging. where the battery becomes used as arbitrage for renewable energy, to accelerate the adoption of renewable energy, store it and move it backwards and forwards, etc. Is that something the West could get better at quicker and flip the script on China's dominance? Any thoughts on that? I mean, you know, Bob, you're smiling. Do you know something?
I do.
Go on then.
We
What do
built
you know?
it 5 or 6 years ago. so we're playing catch up again, Roger, to be quite
God.
frank.
Yeah, okay. Right, I've got a list here, but I'm going to run out of questions in terms of how do we catch up.
Can I opine on the previous
Yeah,
question?
please do.
Because I think the important thing to remember, and this is to what Bob is saying, is that this is all in its infancy. Batteries, lithium development, the whole ecosystem is all brand new. And with anything else, it will mature. And when it matures, I don't think anyone has a crystal ball yet today that can say this is going to be the dominant battery of the future. I think the world is moving towards lithium. I think where it sits on the periodic table and its ability to hold voltage, I think it probably is going to be at least some components and some batteries will have lithium in them. But we don't necessarily know what the technology is going to be in the future because there's so much technology innovation happening today that it's going to change it. And I do think that the answer is probably we don't necessarily design all of these traditional dry cathode-based batteries. Maybe there's other ways to do it.
Yeah. Now, you're running businesses. Inevitably, you're running a business, you need investment. You know, you need a kind of flight path. You have to have some kind of structure around what you're doing. How do we get more price stability in lithium, for example? Because it's fluctuated hugely over recent years. And if you're an investor trying to work out how much your resources are worth over a fixed period of time, it kind of looks impossible at the moment. I mean, you're nodding, Amanda. Is there something that's going to happen to get more stable pricing of this commodity, you know, the supply and demand equation?
Well, I think that part of the problem is that lithium is not a commodity yet, and so the price bounces all over the place, makes it extremely difficult to balance an economic model over a 10 to 20-year period, that's for sure. Yeah. But how do we impact the price of lithium? I think, well, China sets the bar, so we have to compete against China for not just quality, but cost. And when they have the support of the government in all of their companies, essentially, it makes it hard for North American companies to compete. And so part of the solution might be to have our government start giving more money to startups.
Yeah,
So,
yeah.
yeah.
Well, Roger, something Chris said a moment ago is a really important point. Dr. John Warner, who you know, he's a giant of a man, but he's a gentle giant. And he helped me one time put together slides to talk about how long did it take lithium to go from benchtop to actual 500,000 electric vehicles in the United States on highways. 44 years.
Mm-hmm. Oh, wow.
44 years. And I'm honored that I know Dr. Yoshino, Dr. Goodenough, who passed away last year in September, and Dr. Whittingham. But these gentlemen created a whole new paradigm for us with battery technologies decades ago. And it took them that long to figure out that these guys are really smart guys and that they created a technology that really revolutionized the whole world. But it takes time to develop these new systems.
Given that point, it takes time. Is it wrong then for Europe and America to have set these timelines of the finalizing of internal combustion engines, kind of forcing the market without the full knowledge of have we matured the proposition in order to make them in those volumes? Because curiously, and tell me if I'm wrong, they haven't put a deadline on internal combustion engine in China. They're just letting it happen organically. So have we made a mistake putting a cliff edge into this?
I kind of, from a project development perspective, project management perspective, setting clear targets and deadlines that may be somewhat unrealistic, I think helps move the needle forward at a pace that forces innovation, forces different ways to think about things. I don't necessarily think it's realistic, but I think that it's a goal that enables the ecosystem to develop faster. So,
Right.
I think it's a good goal. I don't know necessarily that we're going to hit it, and especially in jurisdictions where you have more challenges like Alberta, where you have long-range cold temperatures. It's not going to happen as quickly in places like this.
Yeah, okay. I would like to take a couple of questions from the audience. So we'll stick the Slido thingy, but what's it called, QR code, up. And if you want to ask a question, you know, please fire away. We've got some time to do that. Whilst you're doing it, let me ask this question to all of you. Confrontation, capitulation, challenge, they're all bad words, but cooperation is a good word. How can we cooperate with China more, you know, more in a way that's strategic? Because at the moment, it just feels like we're building up the wall. You know, we're pushing back on it. And it doesn't feel right. I'm not pro-China. I'm not pro, you know, Europe as such. I'm pro-progress. You know, there's a bit of a mix. But Bob, are we getting this badly wrong? How do we talk with China, given they're in the lead?
Well, most people don't understand the primary reasons why China accelerated their electric vehicle program. I stood toe-to-toe with Premier Li Keqiang in the Great Hall in 2017, and he said, Bob, I got to thank you and Robin Zung for what you guys did at CATL, because we lose 1.3 million people a year in just the 4 metropolitan provincial cities, Tianjin, Shenzhen, Shanghai, and Tianjin. Excuse me, I may have repeated one of those cities, but Beijing. The reason that he was telling me this story is you can only imagine what the tax load is on a socialistic structure by having that many people die, let alone the millions of people that get sick from respiratory failure, from inhaling the P2.5s, the NOx and the SOx that come from diesel and from gasoline combustion engines.
Yeah.
So there's a driving reason why China really accelerated their electrification program.
Right. I promised I would ask your question, so I'm going to do the ones that have been upticked. What are your thoughts around the recycling of lithium-ion batteries?
It's necessary. Yeah, it's going to be a while though before it starts replacing any lithium demand for original batteries. But
they are already over 99% recycle in China today.
Wow.
Okay.
I think it's essential. 100% we need to recycle all these batteries.
Yeah. Well, if we don't, we're in shtuck. So, oh look, that's got 7 upticks. Canada has put 100% tariff on China EVs. Do you all agree with this approach?
I personally agree with the CEO of Stellantis. I think that it's reducing competition from the Western OEMs, and they may not like to hear that, but the reality is that you know, there's no incentive right now to compete against these Chinese OEMs if we just push them out. And so they're going to the rest of the world, and so the rest of the world is benefiting from these. And this is to your point about cooperation.
Yeah.
We could cooperate. We could find ways. We could put time limits on it. We could do it in a different way that would, you know, sort of feed the goal of protectionism, but still also, you know, build industry in the Western world, Europe.
Well, we talked about it earlier. Flip the script. Why don't we basically invite the Chinese in, say we'll do a joint venture. We own 51% of it. You own 49% of it, and we copy what they've done.
Well, they did it with Japanese. I mean, the Japanese, they had the same problem in the 80s. And we managed our way through that. So, yeah.
Well, exactly. So, okay, that's great. Oh, look at that. That's got a lot. How do you mitigate the environmental effects of mining lithium and recycling batteries at end of life? In other words, it's a great and fair question. How do we avoid basically swapping one kind of dirty process, call it what you will, for another? How do we make sure that we have responsible mining, the cleanest technology, that things like the battery passport really work, et cetera? Any thoughts on that, Bob?
Well, absolutely. There's new technology being developed every day. I'll pick on the Impossible Metal guy. He's here at the conference. They are harvesting nodules off the ocean bed floor with giant robots that can withstand the rigors of underwater mining. And I don't want to call it mining because it's actually harvesting. They're actually plucking nodules off the ocean bed floor in a very responsible way because they're using an artificial intelligence interface that looks for life forms. If a life form is on the nodule, it's not going to pick it up. It's going to leave it alone. And it does it in a way that it doesn't stir up the silt bed. As you know, Roger, I've got degrees in chemistry and biology other than spending 49 years in engineering. I think it's important that we exemplify these kind of technologies out there and not badmouth them, because there's a lot of tree huggers out there that want to displace those kind of things. But look at the amount of dirty mining we do on terrestrial Earth versus plucking the nodules off the ocean bed floor.
You say there's a lot of tree huggers out there. Would you please put your hand up if you're a
tree hugger?
I can't see it.
I'll be beat up at the
Bob,
end
I
of
can't
the
see any. There aren't
conference.
any. Right, I'm going to ask, I love this question because I've never heard it before, ever. Will nuclear batteries play a part in the EV industry, and how will this help the West compete with China? I've never heard that question. That's pretty cool, that one. Anybody? I mean, I can't answer it.
How many people in the audience have done crash testing?
That's your answer.
Yeah,
That was part of my job at General Motors while I was there for 21 years, was do crash testing and the survival of batteries. And what do we do with the electrical system after a crash? Catastrophic crashes, if you've got a nuclear reactor in your car, unless you protect it like they do on a nuclear submarine, which is extreme protection, it's probably not the best solution for you and your family to have a nuclear reactor on the car.
Bob says no. Okay, look, I can't believe we've run out of time. Thank you so much. There's so much more we can do. I know there'll be plenty of people who want to ask questions. Obviously, just like with everything else, the team are available to talk to you over the next, are you all here next couple of days? Mm-hmm. Yes. Yeah, great. Not running away, so they'll be here. So could you please show your appreciation for a wonderful panel? Thank you very much. Great, well done.